I'll start off and introduce myself. My name is Michael Greene, and I'm a Principal Program Manager in what used to be called Windows Server System Center. Now we call it the Enterprise Cloud Group. So we cover everything Windows Server, everything Azure Stack, basically anything that you might run in your data center for core infrastructure. And I work within the CAT team within engineering. So that's one of the few PM roles within ECG where you don't necessarily have to live in Redmond. In fact, it's kind of preferred if you don't. Our job is to meet with as many customers as we can and get feedback and then drive that as a priority in engineering. So I spend 99% of my time with the PowerShell team. I'm slowly expanding into Azure Stack as well, but most of my time has been around PowerShell and helping them find customers that are doing things that they should be taking a look at and spending time there. So there we go. So last December, Stephen Morawski at Chef and I had been just going back and forth talking about trends that we were seeing. For a lot of you, especially if you're already working with Azure, or just working in environments where CI/CD type environments are popular. A lot of these concepts are going to be familiar, but what we found was if you were specifically looking at CI/CD pipeline patterns and applying that to configuration as code, so managing core infrastructure, there really wasn't a lot of information from Microsoft out there. There's information about how to build pipelines for Visual Studio for apps and for services, but nobody was really addressing doing that for core infrastructure and then really translating that terminology into an operations language. What does that even mean? If I built my career managing Microsoft core infrastructure, how do I even translate all this stuff? So we wrote this white paper, the release pipeline model, and the name, the release pipeline model, is a direct carryover from what the Visual Studio team wrote their white paper on when they wrote a white paper on using CI/CD pipelines. So that's where the terminology comes from, but anything related to source control, using a build server, releasing to production predictably, same exact model. If you want to get in touch with me after today, my Twitter is just @MIGreene. That's actually probably the best way to get in touch with me. And I'm mgreengit on GitHub, but you'll see me all over the place, and I'm more than happy to share my email address. So the preface we start with in the white paper is there's a book by Thomas Kuhn called The Structure of Scientific Revolutions. And it kind of goes hand in hand with how we organize the white paper. In his book, one of the points he makes is that for an idea to be a revolution instead of just an idea, because ideas come and go all the time, we see trends and things like that all the time, it really has to do two things. So one, it has to solve a new problem, and two, it has to solve all the old problems. So looking at why I think this model is so relevant to core infrastructure operations, as we see the cloud, growing in popularity, I guess, and in consumption, this model certainly addresses being a tenant of any given private or public cloud and how you deploy there. But I think the patterns applied here to core infrastructure in general solve a lot of the issues that we've traditionally had managing core infrastructure. And so basically we walk through what does that look like? What does it look like if you're applying this concept to core infrastructure with and without the concept of cloud being part of that? There's already tons and tons of literature on this. This link here underneath stephenmorawski.com/devops-reading-list. Whenever I'm looking for my next book to go read, this is the URL that I go to because he does a good job sharing information and then keeping track of what he's reading and keeping that current and publishing it. So there's absolutely no shortage. And I should stress that the ideas expressed in the paper and in this talk originated from a number of these different books. So for the most part, it has more to do with applying the knowledge than it does as original ideas. So I mentioned earlier that I meet with a lot of customers, especially within the last year. I'm running into two consistent sets of people. I could go in the morning and meet with somebody and they would say, yep, we're already following this model 100%, but it's mostly on our Linux servers. So, thanks Microsoft for coming by. Can you show us how we do this with Windows? On the other side of the fence, I can go meet with somebody in the afternoon, and they would say, I might actually describe to them, this is what I saw this morning. Are you doing the same thing? And they would say, that sounds something like developers do and not really anything that IT pros do, right? So we're more used to opening MMC console and configuring things that way. So definitely two sides of this process, and this is by far the majority of what I see, and I'm sure you're all familiar with this graphic, which is just, we've got way too much on our plate to even think about or consider how we're going to revamp our process, right? We're way too far underwater for that. So this is the basic idea, and if you're working with Azure a lot, you might be able to appreciate this. So if you look at software as a service for something like Intune or O365, you're really just consuming that as an app. So you get your account, you open Outlook, connect to it, you check your email, and you really never had an opportunity to generalize that environment too much or to randomize it, right? You're just consuming that service. As you move towards PaaS, your service is very consistent, and you as a tenant have an expectation that that web app environment is always going to be the same, and that SQL environment is always going to be the same. As we move towards infrastructure as a service or virtual machines as a service, we have an expectation that the fabric layer is very consistent, but really frequently what I'm seeing is when people deploy virtual machines as a service, the very first thing that they do is go connect into it. Certainly in a lab type setting, then everybody goes through that first experience of, I just want to check and make sure this actually is a server somewhere, and they remote desktop into it. Yeah, wow, this is running somewhere. But even as you get into deploying out projects, it's really, really common that if there's an issue that needs to, that needs to be debugged or troubleshooting needs to occur, the first thing we do is go jump into that machine and we install tools, try to figure things out, remove them. If there's an outage situation, we just kind of beat the machine back into submission. But if it was PaaS, we would go back, look at what's in source control, figure out what's broken, release a new version, and move forward. And so infrastructure as a service brings the opportunity where if we have regulatory baselines that we need to meet, if we've got company standards we need to meet, we can apply all those principles. But then the first thing we do is break it ourselves by connecting into the machine and just randomizing that environment. And it doesn't have to be GUI. You can randomize an environment at the command line just as effectively as you can over a remote desktop. So I think when we talk about configuration drifts, there's a fair amount of that we're imposing upon ourselves by following the practices that we've always been taught, as opposed to looking at the practices that we would use for PaaS and applying that towards IaaS. So when I mention configuration as code and using a pipeline for configuration as code, just to define what I mean by that, I mentioned I work very closely with the PowerShell team. I'm kind of an extension of that group. So usually I'm referring to PowerShell DSC, or desired state configuration. So that's, if you look across Windows Server, traditionally we've got a tremendous number of APIs. So if you were writing scripts for your infrastructure, the way that, or for managing servers, the way that you would interact with the registry is different than the file system, is different than WMI, is different than Active Directory, is different than IIS. So it was, something where from the beginning, you might start with bat files and move towards VB script and then move towards PowerShell. But even across that, you were finding the nuances of each way to interact with the new component that you had to go figure out how to manage. So when I look at configuration as code, I think primarily as I'm building something that, number one, is not just for deployment, it's also for deploy and maintain. And number two, can I take that complex environment and bring that back to just property value? So for everything, no matter what API it is, in the case of DSC, it's using modules under the hood to interact with the complexities of that, but surfacing that into, now I can just have one flat text file, and I can take everything across Windows and make that just sections of a flat text file that say property value, property value. So it should have IIS, it should have a website, the website should be at this path, things like that. As you all have seen, if you're familiar with ARM templates, ARM basically works the same way, Azure Resource Manager, so that's same concept, except for you think more than just what's inside the server. So I'm going to describe, this is how my network should be deployed. This is how my storage should be applied. This is the extensions that I want to spin up for those virtual machines. Here's how load balancers should interact with that. And you could even include PaaS and IaaS environments together. So you could do a 3-tier app where you've got custom executables combined with web apps combined with a SQL layer or whatever database layer you want. So all of that can now be expressed as code. The two things that I would add, so you probably have seen this as well if you've got backgrounds with Chef, but anything in this environment, and the reason I wanted to write this together with Chef is because we work so closely with them to build out an end-to-end solution that combines both DSC and Chef. That becomes your living documentation. So whereas in the past, we all hated writing documentation, now that flat text file is always your current version of what's out there. What's happening underneath that flat text file, a lot of people look at this and say, is this the beginning of the end for my skill set, right? So if now deploying a web server means web server true, is my value diminished? I would argue the other direction, which is that you're able to surface making complex tasks easy, but you still have to have that decade of experience to support that web server, to understand how to take it from version to version to version. Making the language of deployment and maintenance easier doesn't in any way modify the fact that you have to have an expert at the helm understanding for operations how to keep that environment running and just what it means to go from change to change. So we'll get into that a little bit. So the paper is actually divided into 4 sections. We wanted to take the big idea and make it digestible, so we broke it into source, build, test, release. And that's, the paper follows exactly the pattern that I'm going to go through here, which is describe what does that mean for developers, and then how do we relate that back to operations, and how does it contrast with what we do now. So if you look specifically at source control, for me, I identify source control and compare that against what we do with change management today. So just looking at standardized ITIL change management process, and how does source control start to resolve that? So the things we've always struggled with in change management: who made changes, when did that change happen, why did that change happen, was it documented, did we follow the process, things like that. So what did we do before, for the, any point in time before now? So in theory, first, we took that change, we tried it in a virtual machine, we went and submitted the form, we went and presented to the change advisory board. We argued to the board that, yep, this is definitely something we have to do. Hopefully, if 2 people proposed a similar concept and there was potential for overlap in configuration, we caught that. Didn't always happen. And then obviously we update our docs because we're good stewards of our environment, right? So the first thing we didn't do is we stopped prototyping the VM because we really felt confident in ourselves, and we didn't update our documentation because we hate updating documentation. Because why would you want a paragraph about how to deploy a server, right? Nobody wants to write it, nobody wants to read it, so we just didn't do it. The next thing we abandoned is we didn't submit the change form because we're the expert in the environment, and everybody can just accept the fact that we're going to show up to CAB with our idea and it's going to get pushed through, right? So the whole idea of conflict oversight also very quickly got retired. And then pretty much you show up to the change advisory board meeting and you argue, because ultimately the only way for change advisory to work is to say no. Because if you really want to support that environment in a sustainable way, you should never change it. That's why you hear the stories of the NT4 server somebody found running in a closet that's been humming along for 15 years. Nobody touched it, so it just kept running. And then ultimately we end up just arguing. So what do we do now? Everything that we define as how we're going to deploy this server gets documented as configuration as code. Now that statement in and of itself identifies the workloads that we're going to start looking at, because it falls into 2 categories. One is immutable servers, things like web servers that have no state information, easy to throw away, easy to fit into this model. The other side is environments like Active Directory, Exchange, SharePoint. We have DSC coverage in all those areas, but then you're looking at an incremental type deployment. So you're going to define, this is version 21.5 of our domain controller platform. And when we go to 21.6, it has nothing to do with the version of Windows or the version of Active Directory. It's our internal version of a configuration for a domain controller. And so we're incrementing, and that incremental change could be anything from, there's a patch that we're going to roll out. And we could go on and on about whether or not patching should be included in configuration as code. To maybe we're releasing a patch in the environment, but along with that Windows update or a .NET update, there's a registry key that has to be set to make it effective. So that becomes part of our new definition of what a domain controller is. So you have this whole idea of stateful and stateless that you have to think about. And so I mentioned in here, everything goes into that configuration as code, including the scripts that you would use to deploy that configuration as code. So everything that you would define to support this project is going in there. And defining, I think it is important up front to even identify, you're probably not going to take something that's already out there right now and say, we're going to backport in the current configuration for that and try to support it for this model going forward. You might start introducing some baselines through that, but for the most part, you're going to be looking for new projects and greenfield projects, or if you're a consultant and you're building solutions for companies, bringing this idea in as something that's more than just, yes, I can deliver that project for you, I can also evolve your process. So take that solution, we're going to clone it to our workstation, make the change, run tests. So we'll talk a lot about tests today, but pester is 9 times out of 10 what I'm talking about when I say run tests. Push to source control. Many of you probably have seen what it looks like to push to source control. We're going to just walk through some screenshots of that and then resolve conflicts using that platform. So in order to build a quick prototype, and I can connect to this environment live, it looks a lot like it does in these screenshots. So this is just TFS Express. It's the free version for 5 users. I took the screenshots of using TFS because so many people were asking me, how do I recreate this process using Microsoft technology, since I work for Microsoft? The first thing I tell people, though, is in most of the companies that we're going to be talking to, they've already got source control of some kind. It could be any variety. You really ultimately want to integrate with whatever the application owners are already using. Like, try to drive towards that common culture of we're going to agree on tools, because it'll be very tempting for the ops guys to say, yeah, we're just going to stand up our own stuff because we don't have to talk to anybody else. So the more that you can get that integration across teams, at least everybody's got their eyes on the same platform. But TFS has got all the components that we're going to talk about today. So here's a Git enabled repo, and I've just got an Azure deployment template and some supporting scripts checked in. This is in VS Code, and the simple concept I'm trying to relate here is looking at an infrastructure setting. And this could be anything from, I've got a server and it's running on Azure or Azure Stack, and I want to manipulate what that server itself looks like. So it could be, I'm going to add a NIC, I'm going to change where it points for DNS. In this case, I'm just saying, I'm going to try to retire 2008 R2 from my environment, so I'm removing that as an inbound parameter that I can select for deployment. From here, I invoke pester on my machine, so I can look, and I'm basically treating this like unit tests. So in this case, it's just deserializing the JSON, making sure the components that I expect to be there are actually there, that the properties of those components are actually what I expect them to be. And this is just a really quick and dirty set of pester tests for looking at a JSON file. But by running that on my machine before check-in, I just basically do myself a favor and not worry about checking in something that I know has problems before it even goes to source, and then just do a push. In this case, it's just going to TFS running in my data center, but it's still just a Git enabled. You can see by the address that it's actually a VM running in Azure, but it's still just a TFS environment. And I should point out, Visual Studio Online would work just as well for this, as would GitHub or a local GitLab instance or whatever. So over here on the left for my project, I can see I'm actually iterating through. So in this case, I'm retiring the 08R2 option. A lot of people ask, what does this look like in an incremental deployment exactly? So as opposed to defining this is my current version of the thing, saying that I can wipe and reload it anytime, doing an incremental, here I'm just updating Exchange, and moving it on down the line. Because in this case, this was just a web server. So if you're familiar with the concept of continuous deployment, where every time you release, you're going to burn down the old web servers and replace it with a new one, I would look at it for the traditional Microsoft workloads like SharePoint as an example, and say, are we in a state of continual deployment readiness? So I know exactly what's in production. I know I can go look in source control. I can see everything that we've checked in that we trust is ready to be evaluated. And if that server fell over tomorrow, that's what was in production. I can redeploy that. I may have to restore data from backup, but I'm not redeploying the image from backup. And we can touch more on that. But I can see line by line exactly what changed about the environment. So build is an interesting one, and when I first started talking to customers about builds, customers who were following this pattern and what they were doing with build services, I said, so you're driving automation through developer tools. And they said, not really, because we might trigger automation from these tools. So this is the concept that I'm even going to take the supporting scripts for that environment, put those in source control as well, and then everything that happens from build. So and even though I'm developing everything for my workstation, I'm going to test everything for my workstation, I'm going to check this in as a source control and expect that build service should be able to run those deployment scripts to actually make changes in the environment. So I'm extremely standardized about how I take things into production. So what did we do before? We did the work on Saturday. So what was the number one reason why we had to do change windows on Saturday? Because we had no idea what's in that environment. If there was an outage on Tuesday, and I'll take a tangent here for a second, I think at some point the idea of connecting to a server and randomly making changes will be treated the same way as a security vulnerability or a security impacting event, just with less the world's on fire, right? So the idea is, okay, we had an outage on Tuesday. The logs show, Michael Greene was connected in over RDP for 90 minutes. So the conversation goes like, what did you do for those 90 minutes? Well, I stopped and started services, I installed some tools, I did a network trace. Eventually I figured out that this, file was out of date, or, something about the environment changed that we hadn't expected. And so I corrected that. Yeah, so is there a log of that? No. So what's this server look like now? It's the state that I left of that outage, right? So whenever we go in on Saturday and we apply security updates and we reboot that machine, is it going to come back up? Maybe, right? Or it might just fall over. We have no idea. We don't know the predictable state of what that environment is in. So that's why we do it on Saturday. That's why we can't make 10 changes a day. And that's the frustration that we've all lived with. So what we did before, we connect on Saturday. I love using RDC Man. I used to work in ops, by the way, in O365. So I've lived the transition from manual process back in the BPAWS days when we were first building out the labs and things that were going to become the environment, to now this is going to become a real service and we have to automate, or else we can't ever survive. And I've seen these transitions go through. So I always used RDC Man. It was my favorite. I'd go ahead and snap those 125 servers in that pane so I could remote desktop to each one and really configure at scale. So we connected the servers, we reboot them, hopefully in order if there's an application tier. And then we hope that we're lucky, so we might perform a little dance and just hope that when we press reboot, especially if we're working from home on Saturday, that we don't have to go to work, because that's no fun. And then we check that services still work correctly, which usually means if it's something like SharePoint, we open the home page, because we're not application experts. We're just expected to maintain those applications. So of course, we ended up just hoping for the best. That was pretty much what we did, right? For change management, we've got a set of things that we have to deliver. We're gonna just do it, and we'll see, because we know if it falls over, we've got until Monday morning, right? So, and our lives don't matter, so we'll just do that, right? That's great. So what do we do now? Everything's been checked into source control, including everything that includes the deployment. So we're going to trigger that build service. And depending on your platform, and you should also align with the application owners for the build service, that could be anything. For TFS, it's integrated. It's all one platform, so everything works well. It could be, depending on your build service, it could be a webhook that fires. It could be something that runs on schedule. If you're looking at, we always want to be ready to deploy, but we're still going to, as we shift into this process, we're still going to hold for Saturday afternoon, because we're not quite ready to make 10 changes a day, or 1,000 changes a day, or whatever that we get comfortable with. You can still do that manually. So you could standardize the whole thing, and then come Saturday at 1 o'clock, you press build, and it does the work. But everything's extremely standardized, not just happening off our workstations. It's just going to execute whatever you put in source control. So if you put a PowerShell script that's going to deploy a new resource group and stand up a new server, or connect to that server and make changes using desired state configuration, or using Chef or using Puppet or whatever platform you want to use, it's just going to execute that. It's going to perform the work and capture the output. So I'll show you what that looks like. This is an interesting opportunity if you're familiar with PowerShell just enough administration, where you can define a remote endpoint on a Windows node and say only these things can be done in PowerShell in that node. And that's actually delivered using DSC. This creates an interesting opportunity where you can say, for maintenance tasks, we also want to execute that, potentially using an automation platform driven by build, and I'll talk about what that means. That you could actually put a hardened endpoint. And I see this more where the application owners want to reduce the trust between operations and applications. So you might have runbooks that are going to be executed against an Exchange server, and the Exchange admins could actually say, we're going to put a hardened endpoint on this box that only allows the automation guys to do what we say they can do on the Exchange box and stuff like that. So looking back at that project in VS Code, this is a community project named Saki. So if you're familiar with doing a C project, a computer science project in the language C, you use the tool make to organize what that build looks like. Ruby's got rake as a similar takeoff. Saki is PSAKE. It's a PowerShell community project to take the same type of process and define that using PowerShell. So in most cases, there's going to be some sort of gated delivery here, where you've got tasks that need to occur if this passes, go on, if this passes, go on, a task sequence. So in this case, it's just defining tasks. If you look down at the bottom, it's saying go clean up any residual from the last set of tests that were run. Test depends on clean, and it's just going to run pester. And then in this phase, it's running deploy. And actually in the prototype that I've got, now I'm using the PS deploy project. So this is one line, and it's just invoke-ps deploy. So the whole idea is even the scripts that do the deployment should be standardized, as opposed to, if you're looking at Azure Quick Start templates in GitHub, and there's hundreds out there. Most of them, the PowerShell example for doing the deployment is unique to that project. So I like the idea of working with something like PS Deploy to standardize the way that I'm deploying, or especially if we start thinking about Azure Stack and Azure working in hand, the ability to chain together multiple ARM templates and say, I'm going to hand off this ARM template to a resource group in my local data center using Azure Stack, and then I'm going to hand off this ARM template to Azure, or vice versa. A good example for this would be I want to spin up an Azure automation account. I'm going to store some runbooks, put them on schedule, define endpoints. And then over here, within my data center, I'm going to stand up IaaS nodes on Azure Stack. And I'm going to bootstrap them into Azure for management, OMS log analytics and things like that, and have those dependencies defined outside of the ARM templates in something like PS Deploy. In my build definition, regardless of the platform, what I've found, and I've prototyped this together with a few customers now, you basically remove all the default build steps and replace them with just run PowerShell. And the reason is, everybody has come to the same conclusion from what I've seen. It's drive anything unique about running this build into the scripts and put those in source control. And make this portable to where I can run it on my workstation, I can snap it into Jenkins, I can snap it into Travis CI, I can snap it into Visual Studio Online. Wherever I want to execute this, it should be totally portable. So trying to take things out of being stored in builds and shift them into source control, unless it's a defined shared secret, which I store as a variable. So that's what this looks like. Just what's my admin password going to be? In this case, it is bootstrapping the VM into Azure Automation. So what are the shared secrets and the endpoints to be aware of? For TFS, you can actually say via one-click process, if I say continuous integration, it means every time that I check something into source, go ahead and run build. I can also say scheduled, or if I click on queue build, it would run on demand. You can see the output. This is actually kind of fun to watch the first time that you see it, and then after that, it's not a novelty anymore. But you can see the output of the PowerShell script as it's running and doing that deployment. And then 9 times out of 10, you probably have all seen this. If you're working through what I work through, which is trial and error, define the ARM template that I think is going to work, and then iterate until I get it where I want it, you're going to see builds come back failed, and you kind of have to get over the redness on the screen until eventually you get to one that's successful and you're happy with it. And then you can go back and see. Now the nice thing is, now you've got correlation. We agreed upon a change, put it in source control, or I accepted a pull request from another team into our project and put that in source control. Now my build history is correlating when did those changes end up in production. So now I've got a full history of we're accepting these changes to our core infrastructure. And this could include anything from, I could have a build service go out and modify a router or switch configuration too. So you might even work with an environment where you don't have good centralized management of network infrastructure. You could apply this concept there as well, where your build script is just connecting over SSH and delivering a known good configuration. But this gives you that durable record. This is what changed in our environment. And you can rerun it exactly at any point in that timeline on demand. So you could always say, spin up another VM that looks like last week's environment. So this is what I think is going to happen next. And I'm starting to see this now, but I don't see a lot of it. And that is, and I mentioned GIA endpoints earlier, but specifically, what are we going to put in source control? What's going to get run by build? Too many times we've seen, this has been going on for years, where there's a team that does deployments and a team that runs things. And we've all kind of seen the pros and cons of that type of model. So what if the team that runs the deployment, there's a couple of things we want to talk about here, but one of them is define exactly how are we going to do things to sustain this environment. So when you define the scripts that are going to fire as runbooks, and you can store those into SMA or Azure Automation or whatever platform you want for executing those scripts as an operations platform, but you define that in your original project. So before we take this thing live, we know that once a month we're going to patch it. Once a month, maybe we've got a requirement every 90 days, we've got to rotate service account passwords, or we've got a requirement of whatever routine maintenance this application requires, taking the scripts that perform that work, and instead of entrusting a human to once a month connect to all of our servers and make changes perfectly every time, which is unrealistic, write that as scripts and check that in the project before it ever goes into production. And that would include, regardless of what platform you're using, what are the rules going to be for monitoring? When are we going to fire alerts? Who are we going to fire alerts to? Bootstrapping into, are there backup services that are required to support this application? And I've even got one customer, so they're using Azure Site Recovery from on-prem to back up their servers as VMs in Azure. And so they have runbooks in Azure Automation. Their process is, we're going to use build, release a change into production. At that point, the clock starts running, and we've got a 7-day wait. If everything in production continues to go well, then we fire off a runbook, boot the VMs that were originally created as backups of what was on-prem, boot those VMs in Azure, and allow the build service to deploy the new changes out to those VMs and then shut them back down. So as opposed to doing incremental backups once a week, they just allow the build service to introduce change across environments. So I really like that. I thought that was an interesting model. So I'm just starting to see the wave of let's think farther down the road and include that in the process. So this is, Stephen Morawski and I have talked about this at length. We talked a lot about it at PowerShell Summit. If you're just getting started, the one thing you can't live without is source control. The very next thing that you can't live without is test. Right? So this is the number one concept, because let's be honest, you could revise your process, check everything into source control. Now you've got visibility across teams, collaboration, as long as people use it that way. And you're standardizing the way that you deliver change, but you haven't really changed preventing problems in the future, right? You haven't introduced a way to make sure that you're bulletproof going forward. So this is where I see that big change happening. Are we checking our environment? What exactly does that look like? Are we requiring application tests to succeed before we go to production? So once again, what do we do before? Go create the VM, we install the OS manually, install the app manually, we test out the change, then we try the app or service, and we make an educated guess. And that's where I mentioned, if it was SharePoint, we open the home page. We might even go so far as opening a document from a doc library, right? Because now we know for sure SharePoint's still working. If it was Exchange, we'd connect to OA, maybe send an email. If it was Active Directory, can you log in, right? And how do you really prove that Active Directory is still in a clean state of health? 9 times out of 10, it was go check the SCOM console, take it out of maintenance mode, and see if anything lights up. Or don't take it out of maintenance mode so no alerts fire. But Just see if anything turns red. If you open the SOM console and you get to see a green, everything must still be fine. So what did we actually do? We didn't do any of this stuff because after a while we just got jaded and it was too much of a pain and we were moving too fast, so we just didn't test. And we just went straight into production, and then we've all lived through the consequences of that. So what do we do now? That build server is just going to run whatever we put in source. So we start off by saying we actually get linting for free in PowerShell. There's a tool called Script Analyzer, and it's open source. It's on GitHub. The PowerShell team maintains it. The community continues to submit more and more rules, and it goes through and looks at your scripts and just tries to say, is this a well-written script module? And it'll even look for things like, here you said $password, but you made this a string instead of a secure string. So here's a warning to let you know something to keep an eye out for. So you kind of get code quality, and it's driven at the command line, so the build platforms can run it, no problem. You kind of get that for free. And then you get into unit tests. And unit tests are where you can look at your DSC modules as an example and say, this is supposed to deliver change on a domain controller. So this will actually go through and create a new site link, something like that. And so you actually mock integration, or you mock interaction with a domain controller, and your build platform can go make sure that your DSC modules do what they're supposed to do before they ever would end up in production and doing things. The nice thing is for the DSC resources, at least, if you're looking at the GitHub modules maintained by the PowerShell team that end up in PowerShell Gallery, those all come with, for the most part, we're really close to 100% now, at least unit tests and some integration tests baked in, so you kind of get those for free as well. And then integration tests is actually a really interesting one, and I've got some cool screenshots on this, but I'm seeing this area evolve quickly. This is the idea, and those last two, operational validation and integration tests, they kind of get blended a little bit. And I love Test Kitchen from Chef for doing this type of work as well. But the whole idea is let's go ahead and deploy it and then have a script that makes sure that it does what it's supposed to do. So I might have, you can look at it this way. So DSC itself has tests built into it to where it's going to evaluate, is this a domain controller? If not, make it one, right? That's kind of the way the DSC works natively. The idea of a validation test is, can I authenticate? Or, this creates a web server. It's not a web server, so install IIS, associate files with the web service down the line, and now I've created a web server. Well, your validation test is going to say, if I connect to port 80 and I make this specific path request, did I get back the page I was looking for? So it's, does it do what it's supposed to do? And if you get into test-driven development, that's where you can say, maybe I'll write those things first, and then I'll build the solution to those tests. So this concept of integration testing, you can see on the screen, and I stole this directly from that blog at the bottom of the screen, so I give him full credit, but I thought he did a great job. There's no point in me recreating the same thing. So on the left-hand side of the screen, there's just the top of his example for DSC for building a domain controller. Right? It's going to create a forest, it's going to go create a new domain, and then on the right-hand side, there's an example of pester validation tests that say, go make sure that I can actually identify, here's a forest, and what forest mode is it? Did it get delivered correctly? Now let's go check, in this case, make sure that this specific node ended up being a global catalog. Did the outcome of this build do what I thought it was going to do? And this is especially interesting if you're building your own DSC resources, because you could still make a mistake. So even though you've got test baked into that, you could still write the test wrong. So this becomes a check and a balance. And that's what, whenever you run it, it's just going to give you a quick output. And by the way, you'll see it on your workstation when you run it. When it runs in build, the output is an XUnit. And there's a ton of reporting platforms that are all available for free for the most part. So you can have an interesting reporting platform where I've even talked to one customer that they're still working on this, the direction they want to head. They see a lot of temporary networking, weird things happen in their environment. I'm sure we've all seen that from time to time. So they're using OMS log analytics, but they wanted to prove out that when the alert fires, number one, they've kind of got a head start on troubleshooting, and number two, they prove that it is actually an issue on the server and not some temporary environmental thing. So for their monitoring platform, in this case log analytics, when the alert fires, first it triggers a run book to go run validation tests, and then if the validation tests fail, then it fires an alert with those details. So it's not just saying, this web server is not responding to a ping request. It's saying, okay, I found out that it wasn't responding very well, so I went to the server, ran a validation, and yes, in fact, these files aren't where they're supposed to be, or whatever the case may be. So you've kind of got a head start. So this is just back in TFS. You saw that I had 2 steps in my build sequence. The second one was collect those test reports. That's just because TFS already had that build task built in, so you can give it a path to where you expect to see those end unit tests run up. And so here it's just coming back and I kind of get this reporting for free. So here you can see, yep, I ran all 4 tests. They all worked. Great. In reality, you would see hundreds or thousands, depending on the project. We have some with significantly more than thousands internally. So here you can get into the individual details. You can imagine in the case where he had for Active Directory, you've got at least 30 or 40, and you're going to be able to keep track and go back and look at each release. Yes, did we test for those things? So that's actually the number one thing. We've all been in the conversation during an outage post-mortem where someone from management says, okay, guys, how are we going to prevent this from happening again, right? And we're like, well, from now on, Joe's going to check for that email that gets sent from that system, whatever. And so the idea here is our answer can be, we've written a test, it checks for that condition before we go to production, and we know, yeah, something's going to go wrong again because it's a complex thing, but that thing's not going to go wrong ever again because before we go to production, we require that these tests pass. And if you're looking at, in the case where we're hosting this in Azure or Azure Stack, or even if you're driving this as changes via DSC to servers, directly, there's nothing to say that you couldn't either on Azure, AWS, OpenStack, or VMware, or Hyper-V, or whatever platform you want to use, spin up a VM, take your latest that you believe is going to go into production, spin that up, run validation tests against it, and if those tests don't pass, then we don't run that production build against, or we don't run that latest change in source control from build into production. And that's why you saw in Saki, deployed depends upon test. If test fails, don't run deploy. I've yet to see anybody that trusts it so much to say if test pass, just go for it. Right? I know that is happening in the DevOps shops and things like that. And I tread lightly on using the word DevOps, but I know of people using build pipelines in a lot of different environments. But as far as doing incremental updates to core infrastructure, I've not yet seen one that said if test pass, we just go for it every time. It's usually a very intentional release. So here you can drill in and get more details of that specific test. So I am enthralled with this project right now. So this is Posh Spec. The guys at Ticketmaster actually wrote this one, and it's out on GitHub. This is an additional abstraction layer. So where Pester is an abstraction layer to make testing easier running in PowerShell, they wrote a layer that basically writes Pester tests for you. And you just say, it's very similar to things like RSpec and ChefSpec, but describe service. Service, name, status should be running. Describe file. File, location should exist or should contain. Same for registry. I really like the HTTP one. I think that's cool. So when you connect to this machine at this address, you should, on this port, you should get this response, right? That's the ultimate invalidation, is I can guarantee, and we can do this kind of thing for authentication. They've actually got one for hotfix, so go make sure that hotfixes from the Windows Update agent actually returned as successfully installed. So that's pretty cool as well. That one I like, and I think firewall may or may not be, this is a snippet of the example they give on that URL. But I love the idea of sitting down with an auditor, because I've lived this experience as well, and them saying, how can you prove that this firewall port, and it's like it says here, firewall port should be open. What else do you want? Right? It says right here. Oh, well, we also want this port. Okay, I'll add that line. Thanks. The output, this is just running Pester. So in the case where the service was stopped instead of running, you see that test failed. It expected stopped was running. But you're still just getting end unit tests, so you can still use either TFS or whatever reporting platform you want for keeping track of this information and making it valuable. So the very last one, and this doesn't take as much time to explain, this is the least sexy to see and the coolest by far to do, and it's where you actually put the change in production. So what did we do before? We would, and I see so often things that make me cringe here, the process of requesting a VM. And I've heard horror stories of 30 to 60 days to get a new VM, and that's terrifying. So, that we just lived with it, right? And then hopefully the introduction of more private cloud platforms changes that process. But we also had to request environmental changes. So we filled out the form and we requested that the storage guy create the LUN for us, or we requested that the network guy create the new VLAN for us, and that took forever. Once we get the VM, we install the OS, we install the app. Once again, we're not an app specialist, so we all know how that goes. And then we manually onboard the server to everything. So we had a patch management solution, we had an anti-malware solution, we had a backup solution, DR solution, we had a monitoring solution. We more or less went to the file share, got the agent, installed it on the box, onboarded that process. And then we validate it, which like I said is kind of guesswork. And then we go through go live. And there's a couple of things there that I almost leave out. One is, if I deploy 100 of these boxes for the service owner, and 10 of them, they might even write the script for the deployment, but if 10 of them fail, they don't get out of bed at 10 o'clock at night and try to figure out why. It was on the deployment guy, who's not an application specialist owner, or not an application knowledge expert, or I guess just not an application expert. So then we all just kind of did our best and look at logs and try to figure out what's going on. So the application owner wasn't taking ownership of that process way too often. And then for the most part, we went through a go live, which meant, at some point there was still a cross our fingers and, we're going to take this thing live on this date. The users are going to start using it, and that's a big milestone. And then at that point, if it didn't fall over, then we felt a little better. And it was just, it's a constantly terrifying experience. So, I've got those screens on the previous slides that kind of go through taking those away. The reality is for this one, we just did every single one of those things. There's really no humorous way to say, well, we stopped doing this. We just absolutely hammered our way through every single one of these steps. There was no bright side ever. So what do we do now? Again, it's just running whatever we put in source control. So maybe we automatically release when tests pass. More likely, we're keeping ourselves in a state where we're always ready to go to production, kind of that continuous delivery approach. The deployment of artifacts to the environment is interesting because it could mean that we just take, in the case of DSC, we might upload the configuration to the service. We might put them off on the pull server. We might actually connect to an endpoint and deliver that DSC configuration. If we're driving it through Chef or Puppet, then we're just automating those tools to go make changes on those machines. If it's something like ARM, we might be connecting to Azure or Azure Stack and actually releasing changes using those deployment templates. Whatever we're doing, we're basically simplifying a bunch of complex steps. I do see concepts where it's promoting through stages. So the release out of the build platform might just go to a QA environment where users are going to go through and prove out our work before we actually go to production. And then we've got a manual build step that we kick off when we're ready, and we know that users have also validated that environment. So I've seen that. I also see a lot of green-blue cutovers type stuff where there's a web farm sitting behind a load balancer. Part of the change would be if there's a probe from the load balancer looking for a specific file, then it makes a change at the front-end load balancer after a certain number of machines have been deployed, tell it to look for a different file, and you kind of get eventual consistency where all the web servers start catching up with the new version, things like that. So this is an example from PS Deploy. That's just another community project. It's one that I really like. The ARM module is as simple as saying, here's a JSON file and here's a resource group, deploy to it. And here's the parameters that I'm pulling out of the variables in the build platform. So like I said, that one's not the most exciting to demo, but the most exciting to experience. So where do you start? Absolutely with source control, right? Even if it's just getting through, we frequently pull scripts off the internet and we connect to our production servers and run them. Shifting towards, we're going to at least put those in source control so we've got a record of what we've ever been running on our servers, right? Just the baby step into this process. There's no way that this is going to happen overnight. You can start requiring tests before they're run in prod. That's a behavioral thing where we say we're not going to run in production until the tests pass, and there's never going to be enough tests when we start this off, so that's just going to be a growth thing over time. The one thing I would say is for the last couple of decades, as we've built up our skill sets, we've said, I'm the exchange guy, or I'm the config man guy, or I'm the SCOM guy, or whatever the case may be, and you don't want to become the build guy, right? So start thinking about how you can apply this successfully and go back to the application owners and say, I don't want to make an infrastructure change to your servers without your tests passing, and try to make this something that's happening across teams and not just in operations. You don't want to be this guy, right? You don't want to be the build platform is the thing that I'm responsible for running. You want to look end to end across the process. I think this is almost as important as tests. So the idea that when changes are going into production, it's very, very visible. If you've got a Slack channel for your team, I see a lot of email reports. You can't just update reports on a website because people won't go check it, but some way that tells the application owners we've made a change at the infrastructure level. Now, hopefully, they actually had a sign-off process at some point. Well, not necessarily a sign-off process, but they got notified, here's an incoming merger into, they might have accepted the pull request, or they might have got a notification whenever source control accepted the merge or the pull request. But just making that something that everybody knows every time the production environment changes. So it's not a mystery of what's going on out there. The next set of content that I want to work on is just for Windows servers. How do you manage outages without coming back with a totally random environment? How do you, the service is down, what do you go through? And I think the right process is just follow what you do for PaaS. So the same way that for PaaS, you don't even have the opportunity to go connect to the database as a platform service, right? It's just not even an option. So treat IaaS exactly the same way. It's a SQL box running as a VM. That doesn't mean you've got to connect to it, right? You're going to go back and figure out what's wrong and redeploy to it. But it's more complicated than that, obviously. And platform as a service, you're looking at a highly standardized environment. I think we just have to get more rigid about driving that behavior as we go through virtual machines as a service. So I mentioned a lot of community projects. Plaster is a really cool one that's brand new. It's nowhere near done. But that's the idea of you kick off a PowerShell script and it says, what kind of project are you creating? Is it for DSC? Is it for ARM? What does this look like? Is it just a PowerShell? I think right now it's just DSC and PowerShell modules. And then it will create the project template for you. So it'll say, here's an example Saki script, here's an example Pester script, here's an example module. These are the things you're going to need to be successful at building this out if you're running it from a build platform. I mentioned Saki as a way to organize your builds, Pester for test, Posh spec on top of that. OVF is now shipping in the new Insider builds on Windows 10. But that's actually just another thing where it's a way to structure and wrap your tests in a very predictable way so that from project to project we know how to find our test code and where it's at and how to run it. There's a plugin for Slack, and there's a PowerShell module out there around automating integration with Slack. So if you want your build platform to be a bot and drop into your IM session or your Slack channel every time something changes or every time that tests pass or don't, that's totally available. PS deploy I mentioned, and I really am a big fan of that one. Lability is cool. It's a way of getting very, very predictable and simplifying around Hyper-V environments, storing that as config data and using DSC to drive it. So it's a way to very quickly spin up and down VM environments on Hyper-V and to integrate that with build. And I'll close with just one point. Everybody looks at this and says, well, for this to work, I gotta win over the entire business, right? And that's ultimately true. There's really no way around that. But I've seen, time and time again where customers are headed this direction, and it's because one person got really stubborn and said, I think this is the way to do it. And it may not be exactly as I've prescribed it, but it's that departure from the last 10 years of my life, I've been hitting my head over and over and over again, and there's a new concept here. We know we're going to end up going that direction because of cloud anyway. So let's start applying some of these principles, and let's find a brand new greenfield project and see if we can get it to work for that. And he or she just doesn't give up and keeps pushing ahead. So there's some, I mean, you guys have seen user groups, things like that. There's some pretty awesome community stuff going on right now to share ideas and move this stuff forward. So that's my last slide. That's it. Thanks very much.